Hello, Banana Man here. Now, in today's video, I will be teaching you how you can describe a point using three reference magnitudes and four reference points in 3D space. Now, this uses the specific construction, which is like a more primitive polar coordinate system, which doesn't use any convention. Now, what I mean by that is there's no presupposed relation between the reference points here, which are A, B, and C, and D, except for that D cannot be coplanar with A, B, and C. Now, so let's start with how you'd get this red magnitude, this red reference magnitude. So the point A here acts as the origin point in this construction. So to get the red magnitude, it's just the distance from A to E. So that's what it is. Now to get these two blue magnitudes is a bit harder. First thing you need to do is you need to make the sphere from A. You need to make the sphere from A to B, and then you have to make the plane from A between A, B, and E, and then their intersection will give you this big circle that goes through B and F. Now F is just where this big circle intersects with the line between A and E. It's just there so we can describe this arc. Now there's actually two arcs that we could have chosen that are between B and F. We could choose the small blue arc or the big gray arc. And now the way that we disambiguate between the two, between which one we choose, is by using the plane between A, B, and C and using the point D. So if we look at the plane from above, it splits the 3D space into two sides, and the point B, since it's not coplanar with A, B, and C, that means it has to be on one of the sides. So right now you can see it's on the right hand side. So we start drawing the angle that we're going to use from B's right hand side. So we go from the right hand side of B all the way to F, and that's how we choose which arc we're going to use. Because if D was on the left hand side, then we would have started on the left hand side of B, which would have gave us this very big gray arc. And now the same thing works for C. First we make the sphere from A to C. Then we make the plane between A, C, and E. Then they intersect and they make the circle. Then when that circle intersects with the line from A to E, that gives us the point G. And then we pick the arc that starts from the right hand side of C because of where D is. And that gives us this blue arc. So that's how you get all of the reference magnitudes. And that means that if you have all four of these reference points and you have the three reference magnitudes, you can get the point E. Or if you have the the point E and the 4 reference magnitude and the 4 reference points, then you can get the 3 reference magnitudes. Yep, so that's how you do it. And the reason why I'm showing you this is because I'm using this to prove that this definition I made, that the dimension of a subspace, of some subspace, is the minimum number of reference magnitudes you need to describe it, with the minimum number of reference points you need to describe it, which is 4 for 3 dimensions. Since you need a point to measure this red distance from, and you need 2 points to measure these blue arcs from, and you need a point to disambiguate which arcs you're going to be choosing, which is the point D. And obviously we can see that there's 3 reference magnitudes here, and this is 3 dimensions, so it fits with my definition. I checked the same for 1 dimension and 2 dimensions, and you know, this should scale to higher dimensions. Just need to go more in depth on that. So thank you for watching, and bye bye.